Yeah, Venkat, you can start.
Yes, sir. Good morning, everyone. This is Nitish from Genetics, Coimbatore. On behalf of Genetics and Famic Technology, I extend a warm welcome to all of you for our Automation Studio webinar series. Genetics is proud to be an Indian manufacturer of automation products, providing innovative solutions for various industries and offering didactic system for technical education. Established in 1977, and our R&D division is approved by DSIR, and we boast an in-house tool room facility for tool and die machinery. As an manufacturing system certified company, we have a pan-India service facility with our 15 branches across the country and 4 overseas offices in USA, Germany, Africa, and Dubai. Our global presence includes 300 plus supporting engineers and 150 plus dealers and stockers, serving over 1,000 OEMs and 17,000 direct customers. We are also the authorized distributor of Automation Studio in India, and we are excited to have Miss Kalyani Kulkarni from Famic Technology with us today to lead the session. We have a series of webinars planned on various topics throughout this month. If you have any queries, please feel free to write them in the chat box, and we will ensure they are addressed. Now I invite Kalyani Kulkarni to begin the session. Thank you.
Yeah, good morning everyone. So I'm Kalyani from Pamic Technology. So just I will share my screen. Okay, is my screen shared?
No, it is not visible.
Okay, just
You can. No.
yeah, show my screen. Okay, is it visible?
Yes.
Yeah. So just a minute. Okay, so today we are going to see for the analysis of electron technical circuit design using Automation Studio and updated version educational E9.0. The agenda for the today's webinar is to see the DC electrical circuit, residential electricity, AC circuit, illustrated one-line component, PLC control, virtual trainer kit, and at the last we will see some demo files and we will address your questions. So this type of circuitry we will see after the in the Automation Studio for PLC control, AC control. Some demo files we will see. Before that, I will likely to brief about our company. So we have 130 engineers and software specialists. We are ISO 9001 2015 certified and we founded in 1986. We known as leading the industry by designing world-class trade-oriented tools in the field of fluid power, electrical engineering, industrial automation, and custom software development. We have 3 offices. Our headquarters in the Montreal, Canada, one in Germany, and one in the Pune, India. So we have in-house expertise in the field of software development, engineering, industrial automation. So in the field of software development, we have software engineers, database design, network support, multimedia application, object-oriented and web-based applications, and real-time systems. In the field of engineering, we have CAD, pneumatic system, hydraulic, mathematical modeling, electrical system, automation engineering, instrumentation and process control, and in the field of industrial automation, we have PLC, SCADA, human machine interface, electrical control, process simulation, and robotics. We have 4 products. One is Automation Studio Professional Edition, Automation Studio Educational Edition, Automation Studio Live Manifold, and Undone Studio. The Automation Studio Professional Edition mainly used to create, analyze, troubleshoot, and validate multi-technology circuits for industry point of view. In the Automation Studio Educational Edition, which is used to train the future technician and engineers on the hydraulic, pneumatic, electrical, robotics, process control, and PLC system through a simulation. In the manifold, Automation Studio Live Manifold is used to complete the hydraulic manifold software solution for design, coding, and prototyping. And Undone Studio is mainly focused on the Industry 4.0. Our objective is to provide a long-term relationship, effective support by phone, email, or online. We have dedicated representative for each account, and we also provide support materials like training videos, demonstration file, quick start guide, etc. Uh, we our some of the milestones are like in the 1986 we started. In 1989 we developed with the DOS based system, Hydrosim and Neosim. In 1996 we have Automation Studio version 1, and from that we are continuously developing and upgrading software depending on the customer's feedback and the requirement. And now in 2024 we are in the Automation Studio version 9. Automation Studio is multi-user collaboration sharing tool which is used for the simulation, machine documentation, and trade-oriented system design. So in the simulation, we have electrical, electrotechnical, digital, instrumentation, robotics, hydraulic, mechanical, and we have some of the logic development like sequential flowchart, block diagram, workflow, TageWare. So we have many more features. We fits in the multiple programs like mechatronics, industrial maintenance, diesel, agriculture, electrical. You can see here the list. Like last is the automotive. Our key benefits are for student, it used to validate the theories studied in the class, illustrate the system behavior dynamically in full color, reinforces the understanding of the system interactions, and allows to virtually test all types of system. For teachers, it is used to facilitate the demonstration of system interaction, enhances teaching and learning by working on virtual system, easily integrates into the course content, and can be easily handled by both teachers and the students. For school and the universities, it is used to eliminate the need to purchase the single technology software, as the Automation Studio is multi-technology software. It can be used in conjunction with the other departments, limits the purchase of expensive and often inaccessible hardware, and it is used to train the student on leading edge tool commonly used in the industry. We provide e-learning and remote access, like access from the school or from home, and we can create a priorities for teachers and the students, so we can set accordingly. We are available in the 13 languages, and we sold over more than 150 countries, and currently used in the high school, career centers, colleges, universities, and workforce development. Uh, so from this we can see we in the Automation Studio we have some example which is already created. So this is the example from the Anthony fluid power with application. So from that circuit we have taken some of the example, we created the circuit accordingly, and we have seen the effect. So student can use this type of circuit, and after studying or analyzing they can create their own circuit. So this is the one of the advantage. Then there are some interactive exercises, so that can be easily customizable. So anyone can just see the steps and follow the instruction and do at the start. Then digital twin of our own equipment is also possible through the OPC server client. Then we have some illustrated libraries for PLCs, hydraulics, AC/DC motor control, pneumatics, as well as some of the residential electricity and the one-line logics. So we will see it later. Automation Studio provide you to create your circuit in the form of symbolic, in the form of illustrated component or virtual trainers. So all these possibilities are possible in the Automation Studio. So Automation Studio is advantageous over a hardware kit. So this is the just video recording. I will just start that one. So this is a pneumatic trainer with the hardware. So you can see the hardware connection is, so someone is doing a hardware connection. So the same things can be reflected in a virtual trainer. So we will see that one. So here it is the software. So in the software, we can just create a connection and we just observe that one. And in the digital twin, it is possible to move this logic via the OPC server. So I think you get an idea the difference between hardware and the software. So so accordingly, the benefits of the hardware only and hardware and Automation Studio is like it will save your time as well as it is a less expensive option. So if we consider hardware only student per unit can do the experiment. But if we have two hydraulics and the Automation Studio with the 20 users of Automation Studio, then they can do by ourselves, and it will take a less time, as well as this is a less expensive option. So again, the Automation Studio has the most important feature like a manufacturer catalog. So we have the catalogs for these many of manufacturer like Agrohytos, Danfoss, Humphrey, Eaton. So in this catalog, you will get access the component from that series. So this is the most important feature. So this is an example where we have accessed the component from this catalog. Like you can see, this is a component from the this is a pilot operated component which is taken from the Bosch Rexroth group, which is taken on the test bench, and you can use it in your circuit. So it is directly used component. So this is the structure. This is the online catalog. So from here you can access the component. Then this is the partial list of our industrial client. Like in the aerospace, we have Airbus, NASA. In agriculture, we have Aegis, John Deere. In energy, ABB. In forest, John Deere. In construction, Caterpillar. In defense, Larsen and Turbo. In meteorology, we have the China Steel. In mining, Epiroc. In offers, Cameron. In transport, Honda. In system integrators, OMAC. And in handling, Skyjack. So these are the list of our customer. Then Automation Studio also provide you the complementary consultancy services. So these users ask us for the this type of manifold. So we created for them. Then Automation Studio provide you the training, maintenance, and service like which provide you the on-site training at customer premises. Then Automation Studio training consulting on specific project, including advanced topics and the concept. Then software development and consulting services. So everything can be supported. Sorry. So this is about our dynamic technology. So we will just see for the demonstration. So this is the screen for the Automation Studio interface. So is it visible?
Yes, it is.
Okay. So at the top you can see the ribbon bar. We have the different tabs in that like home, edit, view, simulation, system analysis, fluid, tools and support. So in the home tab you can see we have different tools like components, documentation, links. So these features are related to the suppose this is a library, so we can access the library by clicking over it. In the edit tab we have different editing options. In the view tab we have the display options like a zoom, as well as we have some window settings. In the simulation we have different simulation options, as well as some of the dynamic measuring instrument. So each of this tool defining the certain category. At the right side you can see the project explorer. So whatever the project is currently open we can see here. And at the left side we have the library explorer. In the library explorer we have different technologies. So like hydraulic, hydraulic, pneumatic, proportional pneumatic, drive and transmission, environment and control, electrical, as well as electrotechnical, IC and NEMA, ladder logic and digital electronics. So these are the technologies are available in the Automation Studio, and in version 9 this is the technology like a robotics is added. So so in the hydraulic you can see the component related to the hydraulic like pumps and intensifiers, reservoir. So and in the so as our main agenda is electrotechnical, so we will just see for the electrotechnical component. Yeah, so in electrotechnical IC we have two standard, IC as well as NEMA. So in the IC we have components depending on its behavior. So we have the lines and connection. Again in the lines and connection we have many more components like terminals, links. So just clicking on the tree structure you will find the component related to that behavior. Suppose it is a control, so we can see the control related component like protection, relay contact or signaling devices. So if we click on the signaling device you will see the component according to the signaling devices. So this is the categories are created in the Automation Studio library. In the electrotechnical NEMA, the same components are available, only the compatibility will change. So to have that this component on the workspace, so this is a workspace, so you can drag and drop this component on the workspace. But before that, if we are using the electrotechnical component, so we have to take a new project with the electrotechnical compatibility. So as we have as we have this as Automation Studio is a multi-technology software, so we have these many of technologies like a standard diagram which is related to the hydraulic and pneumatic, and electrotechnical diagram where I want to use electrotechnical component, so I will use electrotechnical default. Again, we have one document like a multi-technology diagram. So if we take this document, so all technology components will be accessible on this document. So on the electrotechnical, we will just create one DC circuit and one AC circuit just to see the effect of AC and DC circuit. Okay. So from the electrotechnical IC, I will take one battery. So this is a 24-volt battery. So to take any component, you have to just drag and drop that component on the workspace. Then I will take two resistors just to see the effect of the Ohm's law as well as to see the ability of the automation studio. So I will take one resistor. So in the electrotechnical IC, we have one category like basic, passive and active components. So from here, I will take two resistors. So I have this resistor. Again, in the resistor, we have many more types. So from that, I will take this one. And if we click on any of the component, we have the property window. Here user can set the different parameters according to their need. So if in the parameter control, we have three types of control like a parameter, what is the value we have fixed, with that value that register will work. In the slider, during the variable during the simulation, we can change the value of that resistance like a rheostat. And in the variable, we can link any type of variable with this register. So instead of maximum resistance 10,000, I will change to 1,100 or okay. Okay, so I took 100 and I changed this control to the slider. So during the simulation, I have the facility to vary the register. I will copy the same register by just clicking Control and plus. Okay, I will make a connection. To make a connection, you just have to click on the one port to the another. And again, we have some options for the wire. Like here you can see control wire, power wire. So you can use this type of wires also. Again, we have some of the measuring instruments. So we will use that one. Here in the measuring instrument, I will use 1 voltmeter to measure the voltage across the first register. One more to measure the voltage across this second register. Okay. Okay. So this voltmeter will measure the voltage across this first register, and this voltmeter will measure the voltage across the second register. So we have used this measuring instrument from the generic library, and I will use one ammeter to connect it over here. Okay, so just to measure a current. Again, if we click on any of the measuring instrument, we have the precision tab. So you can change the precision as well as you can change the unit. So I want in milliamp, so I will change it to milliamp. Okay. So now if I start the simulation according to the KVL or the Ohm's law, you will see the effect like we have given 24 volt to this battery, so that this 24 volt getting divided into 12 and 12 volt across these two resistors, because the value of resistance for the both of these resistance is equal. If I vary any of the resistance, you can see the effect during the simulation, that voltage value is getting transferred to the minimum value. And as well as this is the current flowing through the circuit, so as per the total resistance, that current is increasing or decreasing. With this, we have dynamic measuring instrument. So here in the simulation tab, we have this measuring instrument. So we have single node, two node, as well as three node dynamic measuring instrument. So single node dynamic measuring instrument is used to measure the current. So if I want to measure the current with this line or with this wire, so I can just click on that component. I will highlight with the purple color and I can measure the current. So you can see the current through the measuring instrument from the library and through the dynamic measuring instrument is same. Again, we have the multimeter clamp for troubleshooting tools. So if I want to measure the current by using this, I can just clip this take this clamp over here, so you can see the current through all this instrument is nearly same, means 143 milliamp. And suppose I want to measure the voltage through the whole this multimeter, like in the library we generally use this type of instrument. So here also we have the option to use this type of instrument. If I want to measure the voltage across this, so this is a 14.3 volt. Why it is not? Just a minute. I just redo the things. So I will measure the voltage across this. Just a minute, because of I think this measuring instrument, it is getting reflected. So yeah, so here you can see the voltage because of this dynamic instrument, the resistance value was getting changed and it was affecting. So this type of circuit components you can use during the simulation. Again, this is nothing but the DC circuit, and it is nothing but the we just verified the KVL, and how we can see how this is the real time simulation is working. Now we will create a simple AC circuit just to see the effect on the AC component. So from the electrotechnical IEC, I will take one three-phase source, one circuit breaker. So this is a thermomagnetic circuit breaker, 3-pole, and I will take one motor. And in between this, I will use one contactor pole. Okay, just to activate this motor externally. And again, as I explained, in the home tab we have this wire option. So instead of creating single connection, I will use polyphase wire configuration, and I can connect it like this one. So it saved time as well as it avoid the wrong connections. Now to activate this contactor pole, I will take one contactor coil. So from the control, we have this contactor coil. So I will take this contactor coil. From the power, I will take one transformer just to change the voltage level. And from the switches, I will take one switch just to start and stop my motor. This is just for starting purpose. Start. Okay. Just to make a connection. I'm giving supply from the same three phase, and as explained, we have the data property for each and every component. So for transformer also we have this property like primary voltage, efficiency. So for each and every component we have the parameter settings. So depending on the requirement we can just assign the values. Okay, so to link this one we have to just give name to this component. So I will just give name C to this contactor coil, and I will link this C with this contactor pole. So we have this variable assignment option for each and every component. So here the C is getting reflected. So the same contactor coil I have linked to this C. It means that when my contactor coil C will get energized, this circuit will come into operation. So now if I start the simulation, when I close this one, it will not work till this is getting energized. So if I close this one, the coil is getting energized and my motor is running with the 1500 rpm. So again we have oscilloscope. For this I will just show you the oscilloscope operation. So this is the oscilloscope like we use in the laboratories. So if I want to measure the three-phase voltage, so I just connect this one to this. Like in the laboratory also we create this type of connection with the oscilloscope. So you can see at a scale, so you can change the volt per division, we can change the time per division. So this type of waveforms are getting created. Again we will see for other phase. So again, we have the auto scale option. We have the scale division option. So you can change and you can observe your waveform. So this is the use of oscilloscope. Again, we have the plotters to plot the different quantity. Suppose I want to plot I will take one of the plotter. Suppose I want to plot this, what we can say, we will plot angular speed of this motor. I will just plot over in the plotter. So, and if I start the simulation, again in the plotter, we have different option to set the color patterns, to set the line patterns. Everything can be editable. So you can set according to your need. For now, whatever are the setting, I just show you that one. So if I start the simulation, now nothing is there. If I close and if I start, you can see how the speed is getting changed in the plotter. Again, you can display the legend, what type of variable we have plotted. We can just annotate it for this particular value, and we can change the zooming pattern of that plotter. Again, you can export this plot in the .txt format or .csv format if you want to have it in your publication or in a documentary purpose. So this is the use of the plotter. And if you have any doubt, you can put your question in the question panel, so we can just address it, or after the session we will just see on that. Okay, so this is nothing but the AC and DC circuit. Now we will see the circuit which is available with me. So I will just open that circuit. So if you have any question, you can put your question in the question panel. Yeah, so this is a circuit. Just we created a simple circuit by using the battery and resistance. So this is a circuit to verify the KVL, and this is a circuit to verify the KCL. So from this example, you can understand, you can simulate any network theory in the automation studio. So like a superposition theorem, Thevenin's theorem. So that type of experiment you can do with the automation studio. So if I start the simulation, you can see according to the KVL, this is the input is 24 volt, so it is equally divided as per the resistances with that loop. And in the KCL, the incoming current and outgoing current is same, and this is the branches. It is dividing into 6 milliamp because of the resistance is equal, and this is in ampere. But if we change this to milliamp, we can see the incoming current and outgoing current is same. So this type of theorems can be verified or proved in the automation studio. Again, this is a DC motor. So speed of the DC motor is controlled through this resistor. So this is a variable resistance, and you can change this value of resistance during the simulation like a parameter, like a slider. So you can see now it is nothing is there. But if I change this resistance, the motor is getting started with a particular speed. So if we want to observe some of the DC motor operation, or to observe some of the circuit theory network theory theorems, so you can also do in the automation studio. So after this, we will just see for the next topic we have in the agenda. Just a minute. Yeah, so the next topic is residential electricity. So for the residential electricity, you can see below the library explorer, we have this orange icon. The orange icon is nothing but we can, if we click on this orange icon, we have these many of illustrated libraries in the automation studio. So after clicking on it, we have these many of options. So according to the need, we will just open. So as per the agenda, we have to see the residential electricity. So this is for the residential electricity for European, and this is for North America standard. So I will just open any of it. Yeah, so if I open, the different library has opened in the library explorer. Just take a new project. Okay, so here in the residential electricity, we have the switches, we have the lights, photo sensors, outlets. So this component as per the illustrated view. Suppose I take one fan from this, and if I energize it with some of the source, so if it is, I take a power source, And if I connect it with this, and if I start the simulation, this fan should rotate if I turn it to on. So you can see this is rotating. So like this circuitry, if you want to just demonstrate, you can just create and you can just observe the effect. For this one also, I have one example to just show you. Just a minute. Yeah. If we click on this new project, sorry. Yeah, new project, we have this many of templates. So from this template also, you can take a template like in the electrical, in the virtual trainer, in the residential electricity. So we have this many of project already available. So anyone can study on it and work on it. Suppose I will take one of the file from this. I will take ceiling fan. So we have the illustrated template for some of the application. So you can see this is the just a prerequisite created for the ceiling fan. So we need to just make a connection. So to create a connection, we have to click on the port. So if we click on this green one, so green is nothing but the ground. So this is nothing but the banana cables. So you can change the its sizing and the its curve pattern. Again, if you don't want to use a banana wire, you can just tick for the control wire and you can make a connection like we did previously. So I have given supply from this one and I have to give supply to this. We'll just make a short connection. Yeah, and this is a brown one. Now from the mains also, we will take one of the supply. So for ground, yeah. So this is a ground wire and this is a supply. So what happened when we start a simulation, we have to just start with the main, then with this phase, and then this fan will start rotating. And same for this lamp. So we have one lamp. Now we will take a direct wire instead of core wire. So for core direct wire, you can see this type of connection can be possible. Yeah. Now we will just start the simulation. Yeah. So now the fan is not rotating, but first I need to give a main supply and then this phase supply. So you can see this is working, but we need to check for this one. Lamp is not glowing. So fan is rotating, but lamp is not glowing. So these connections, yeah, brown one, green one, and this is a blue one. Yeah, these connections are remaining. Yeah. So now again we will start. Yeah. So this type of illustrated templates you can create. You can use this type of illustrated template which is already available in the library and you can use it in your circuit. So you can see here the lamp is glowing as well as fan is rotating when we will give this supply. When we activate this both supply, it is working. So by taking this of the reference file, you just practice on this type of example. Again, I will just open one more example which has the lights, different lights and the relay logic. So connections are already made in that circuit because of time limitation. So yeah, this is the two lamps which are connected in the series. So by activating this fuse, we will see the lamps are glowing. So this is a power source. This is the connections I already made and this is the lamp which are glowing. So this template is again taken from this new project and from this electrical virtual trainers. So we have many more. We can just practice that one. So after that, we have some of the illustrated one line components. So for that also we have this illustrated library. So from here we have this illustrated one line illustrated component. If we click on it, you will see the components which are compatible with the illustrated one line. So for that we have to take the project, that is a one line diagram. Yeah. So if I take a one line and if I want to use these components, that can be compatible on this document. So I will create some simple circuit for it. So I will take one transformer. I will take one source. Suppose I take a solar farm. So in the source, we have the different types of sources, like a different types of plant, wind farm, nuclear power plant, fossil fuel power plant, hydroelectric power plant, and solar farm. In the transformer, we have power transformer and distribution transformer. In the transmission, we have different poles and the transmission lines. And in the loads, we have small, large industrial buildings. So these loads can be used. So I will take small house. Yeah, and for transmission, I will take this just for example. So what this solar panel will provide, it will provide you the 25 kilovolt, because here in the property we have set that one as a 25 kilovolt. So that 25 kilovolt can be given to this transformer. This is a step up type of transformer which will convert this 25 kV to 125 kV. Now this 125 kV is given to this pole and then to this line. This is just for demonstration, but in actual practice it is not like this one. So if I start the simulation and if I measure the point, so here, yeah, by using this tool you can measure the voltage. Yeah, yeah. So here the voltage is reduced because we have connected some of the load. Suppose I disconnected this load, it will give us the same voltage which is coming from this solar panel. So the effect is like, if we connect any type of load, the effect on this, that the series connection will taking into consideration. So for this one also I have one file, so just show you that one. Yeah. In that we have power grid, different industrial and the small house connections are there. Yeah, it will take some time. So if you have any question in between, you can just put your question in the question panel. Yeah. So this is a hydroelectrical power plant, and there are different power transformer and distribution transformer are used. This is the pole configuration is used. Like in the actual practice, this type of connections are there. So this is the transmission system. This is the industrial load, and this is a small load like a home appliances. Here again, it is transfer to the different loads. So this is a transformer which has the settings. So you can change to the star to delta or zigzag. So for each component, you can set the different parameters according to that component behavior. Suppose we have the poles, you can change the frequency, inductive reactance, resistance. Again, you can just control on it like maximum and minimum value. This is the load. So for the load also, you can change the ratings as per you have in the actual practice. So this is a one line power grid. Then after this, we will go to the next point, that is a PLC control. So for PLC control, we have one more another library, like here you can see we have this PLC, illustrated PLCs. So if I open this one, you can see, I just click on the new project first. Okay. So we have this type of PLC for different manufacturer, like for Allen Bradley, Bosch Rexroth, Eaton, Koyo, LS Electric, Mitsubishi, Omron, Schneider, and the Siemens. Again, if we click on any of the manufacturer, you can see we have two type of template, like for standard diagram and for electrotechnical diagram. So as we have seen, we are multi-technology software. So if you want to use the Siemens PLC in hydraulic or pneumatic type of document, so you can take this PLC from the standard diagram, and the same PLC is available in the electrotechnical if we want to use it in the electrotechnical compatibility. So if I tick any of the, suppose I take this one, so this is the PLC which is created by following the specification sheet which was provided by this component. So if we click on the any PLC again that have the variables, and we have the option to do the variable assignment. So mainly we use a SFC ladder logic to operate the PLC. So for that one, instead of this, I will take one of the illustrated template from the PLC. Now I will go to this PLC. We have virtual trainers, and from this one I will take Siemens S7 1200. So we have these many templates. So but from that I will just choose this one. Yeah. So yeah. So this is a Siemens PLC, and the pre connections are made like what we need, but the logic is not created. The PLC is same from the illustrated template, like from this one. This is the PLC from Siemens and whose name is Siemens S7 1200. So this PLC is used over here, and this is the switch configuration for input, and this is for the output. So to operate this PLC or to see the working or the functionality of this PLC, we have to create some sort of ladder logic. So for ladder logic, in the generic component, we have the different ladders. So you can see ladder diagram for Siemens PLC, Allen Bradley. So these many of ladders are possible. So for that one, I will take Siemens PLC. So we already have rung. I will take one normally open contact and one out. So out for suppose first port. So it means I will activate this A0 with this ladder, with this first line ladder. Okay. Yeah. So here I will link this A0 type of port. So when I will during the simulation, when I activate it, it this contact will get activate, and if I activate this contact, this output will get energized, and we will send this output signal to this out, so that the lamp connected to this output will glow. So here I will link I 0.0. It means that this I 0.0. So the naming convention is same as per the specification sheet. Again for out, I will link Q 0.0. Yeah. Now if I start the simulation, and if I close this one, you can see this A0 lamp is glowing. And here the logic is getting transferred. When I activate this, it will get deactivate. When I activate this one, it will get activate, and the signal from this one is transferred to this A0. Again in the ladder, we have the different components like a rung, bit logic, timers, counters, comparator, converter, like move and jump condition. For now, I will create for one more line for that by using the timer. So I will take one timer. Again, I will take one normally open contact and one out. Okay. Now I will give name this to the 2. The 2 will be nothing but to activate this A1. So naming convention can be given as per the necessary. Okay. So if we click on the timer, we have the option to change the time. So by default, this time is 10 second, and again time base value is 1 second. It means that this 10 is nothing but 10 second. Suppose I change anything other, suppose I take it to 1 minute. So this 10 is nothing but 10 minute, like that one. So you can change this time base value and the preset value. So now I kept it as a 10 second. I have to link some of the input and the output. So I link A1 to this one. So in the variable assignment, I 0.1 I will link to this one, and here Q 0.1 I will link. Okay. So what will happen if I start the simulation according to the timer? If I click on this A1 port, it will take a 10-second time to activate this A1 lamp. But for A0, it will glow instantly. But for A1, you can just see for A1 it is not blink. but you can see here the time is getting counted. So when it will be 0, this A1 lamp will get activated. Yeah, so you can see here this A1 lamp is getting activated, and again on the PLC this type of LED to just show the status. So that is also available in this PLC. Not only this, but all PLCs have all that functionality, like to show the status of that particular out or input. So on PLC also you can see the status, as well as on the output or input. Means if we see the status here, like if I click over here, I can see here this. If I click on the A0, my logic is getting transferred and this A0 lamp is also glowing. But sometimes this lamp will not glow, but out will give you the status that is activated. So anyone can just understand that from the PLC there is no issue, but from the lamp there may be some issue. So you can just see the settings for the lamp, because for every lamp we have some voltage rating, min and max rating. So that can be setted according to the need. For the PLC again, we have one example just to show. We'll just open that one. That is an industrial example actually. So I will just open that one for the drilling index. Yeah. So this is the example as an industrial point of view. So this is a virtual system for the drill index table, and this is the ladder logic. So this is the PLC, which is not actually for any of the manufacturer, but we have some PLC cards. So from the PLC cards, you can create a logic and you can use it in your circuit directly. So now if I start the simulation and if I activate this start command, the operation for the drill index table will start, and everything can be flow in a sequential manner as we provided in the ladder logic. And here you can see there are different sensor to sense the position of that particular cylinder. So it will sense the position and accordingly it will give you the status. So you can just see how object is going, and it is pressing the object and it is again transferring to the particular level. So this type of industrial example are also available. So in the new project, in the virtual systems, suppose I want to see for the cement. So you can see we have the intersection, drilling factory, metal bender, car wash. So these examples can, you can just refer this type of example to create the own experiments. After that, we have the virtual trainer kit. So virtual trainer kit is nothing but what we can see over here. So I will just show you one or two more. For the relay logic, I will show one of that. So in that, the what we can say cylinder position is controlled. Yeah, here the cylinder position is controlled through this electrical logic. So if I start the simulation and if I give the start command, it will just control the position of this cylinder. If I stop, it will stop the, it is not press. Yeah. So this type of sequence can be possible by giving this type of relay logic. So these are the component from the we can say hydraulic or pneumatic virtual system, and there is a logic through the electrotechnical. Again, we'll show one of the example for the motor control, which is also the trainer kit, and the connections are already created. If you have any question, you can put your question in a question panel. Yeah. So this is a motor control. So these components are taken from the illustrated library only and from the motor control and renewable energy. So again, each and every illustrated library has some different components according to the naming. So in the motor control and renewable energy, we have the components for the renewable as well as for the motor control. So this is the illustrated template is created by taking the component from that particular library. So this is the start button. This is a supply to just giving a supply to this motor, and this is a control logic to just to control this motor in the forward and the reverse direction. So the control of the motor for the forward and reverse direction is by taking a phase sequence into consideration. Again, we have used some measuring instrument from the illustrated library. So in the illustrated library, we have this type of measuring instrument which can be visible like we have in the actual practice. Here we can see the motor speed. So if I start the simulation now, if I close this push button, sorry, yeah, firstly, yeah. So if I close this push button, the connection is for forward rotation, but I close this. If I stop and if I close this second push button, this is for the reverse rotation. So in the forward rotation, this first contact will get activated. Like if you see, if I start, yeah. So in the first condition, this first contact is getting activated and the motor is rotating in the forward direction and the current is 4.7 amp. So, and this is nothing but the for reverse rotation. So if I control through the second push button, because you can see the connection is from this contactor coil and the poles. So if I push this one, you can see my motor is rotating in the reverse direction. Again, we have some of the constant low torque. We can vary it and we can just observe the operation. Yeah. Uh, Apart from this, so these are the some of the demo files. Again, if anyone want to see some of the demo files, so in our on the FAMIC technology portal, we have some demo files to just see. So from there, anyone can see what type of applications can be possible. So from the demos, I just open that one. Yeah. So in the demos, we have this many of template like robotics, electrical. Again, if you click on the electrical, you can see we have motor control. We have suppose PID tank level control, Ohm's law circuit. This type of circuit we already seen. So anyone can see the different project from here. Suppose I click over here. So this is for the digital control and you can download it and you can just see the operation. So here also this is a lamp solution. So this type of circuitry we have seen, but we have many more in this demo. Again in the PLC we have different demo files, so anyone can just see the operation. So here you can see the traffic light. This is a ladder logic for it. So according to the logic this will work. So again this is a industry point of view. So this is a for the forward and reverse of the converter. Yeah. um Again we have the other feature like a online catalog. So in the online catalog, if you click, so in the home tab we have online catalog window. In the online catalog you can see like I explained that we have most important feature like a online catalog. So in from the online catalog you can access this many of catalogs. So what inside in this online catalog we will just see. Suppose so this is a list of the catalogs. Suppose I want to see the Booker hydraulics. So these many of catalogs are available. Suppose I click on any, I just need to accept. So this is a hydraulic catalog. But suppose I click on the what we can say headache. We have the filter option again. I will click on the electrotechnical. So only electrotechnical catalog will be seen over here. So from here, I will just see Hydac electronics. So in the Hydac electronics, you can just see the list of the components what we have in the catalog. So in the electronic, we have this three structure: electronic sensors, controller, and display. And this structure is accordance to the website for the Hydac. So in the electronic sensors, we will see these many of sensors are available. These are controllers are available and these are the display. So again, if you want to take any of the component from here, or if you want to see the operation for that component, what you have to do is like you have to click on that component. So from here at the right side, you can see we have the component, but first we need to configure it. So for configuration, we have this product configurator. So from here, you can just configure and take that component. Again, the reference for this component is available in the documents, like here it is the PDF and here it is the PRX. PRX means the project like we seen in the automation studio. So by downloading this document, you can just see the same component and its operation behavior in the automation studio. So that that is also possible in the automation studio. So for a different catalog, we have different strategy. Like here in the Parker, we have this strategy. So you can access this online catalog components. Yeah. So I'm done from my side. If you have any question, you can just put in question panel. Yes, Saurabh, is there any question?
No, currently there are no questions. So yes, so anybody has any question, you can just type the question in the question pane.
Yeah.
So likewise, we have next set of webinar. Okay. So in the next webinar, we have the topic that is aeronautical electrical circuit design, which is on 21st October, that is Monday. Okay, please do register for that webinar. Okay, so if anybody has, okay, so nobody has any questions, so we can end the session. Thank you very much for attending the webinar.
Thank you, Saurabh sir, and thank you to FAMIC team. Hope all the attendees are gain some knowledge in FAMIC, from FAMIC technology. If you have any doubts, just put it on the chat box. We will respond to it. And thank you all.
Yeah, thank you very much. Have a good day.